So what we'll be covering today, talking about good relational design. Okay, we've covered these principles before. It should be reviewed. Okay, we're going to talk about decomposition, talk about normal forms, cover atomic domains just a little bit, talk about the process as a whole. Okay, we're going to talk about temporal data. All right, none of this is very complicated. Well, let me rephrase that. We're not covering the complicated stuff. How does that sound? All right, because you start getting into fourth normal form, fifth normal form, and you're looking around like, what's the point of this? You know, I don't know. It's there. We're not going to worry about it. All right, good relationship design. One of the most important parts about a relational database is having foreign keys that are able to identify the relationship. Okay, and who can tell me why that's important? Why is it important that foreign keys identify relationships? Exactly right, okay? So I think maybe 2 weeks from now or so, we're going to start in SQL. All right, when we start in SQL, we're going to build basic databases. Okay, we're going to implement basic queries. All right, when we start putting tables in a schema, all right, what you got to understand is if you're wanting to get information and do joins, you have to have something in common. Okay, that thing in common is a foreign key, right? So that's a very important part. Okay, atomic attributes. This is also a review. All right, what can you tell me about atomic attributes? Exactly right. Okay, so if I were going to put, let's say I had a student entity, and let's say I wanted to put courses taken. What's the problem with this? Could have taken the same courses, so that's if it were primary key, but just let's assume that there's other stuff in here. This is just one of the attributes. What's the problem with that? Do you take more than one course? So if this is a single attribute here, what are you going to do about it? It's not atomic, right? All right, so decomposed. All right, decomposed means that you don't have stuff like this present. Okay, what you're going to do is anything you can break out, you do break out. All right, so you know, a basic example of this would be to have like a registration table. Okay, so you would add in a registration and then put all the information you need for it. And of course, it would probably be what type of entity? Associative entity, exactly right. Okay, because it's going to probably be between, say, student, registration, and let's just say section. All right, something like that. So for the associative entity here, what are its primary keys going to be? Student and section, exactly right. Okay, and when we form those, a primary key using multiple attributes, what is that called? Composite key. What's another name for composite key? Starts with an S. Super key is exactly right. Okay, so basically interchangeable. So that's decomposed. Anything you can pull out, you do. All right, and in general, you can kind of think about this. We're going to talk more about decomposition as we go. But just think that any of the fields, or any of the attributes rather, that are inside of an entity, they should only relate to the primary key, nothing else. Okay? Does that make sense? Logical. So logical should be pretty self-explanatory. You're doing good relational design. If it doesn't make sense to you, it's going to make sense to someone else. Okay? So logical. Now, what goes into determining if a ERD is logical? What are some things? Throw some stuff at me. So the name's making sense. That's a good thing. What else? Cardinality's got to be logical. Absolutely. What else? So labeling the primary and foreign keys and also having them make sense. You know, so a primary key has to fulfill the requirements of a primary key. All right? Courses taken, if it were a primary key, it'd be horrible. Okay? There's so many reasons why courses taken would be horrible. What else can we think? I don't mean to fuss, but do remember participation, 10% of your grade. What else makes an ERD logical? All the entities. That's exactly what I was thinking of, you know. So you do that in the brainstorming phase. You know, you gathering requirements. You figuring out what you need to include. Include them all as entities. Exactly right. Anything else we can think of? I think that's good enough for now. Okay, minimal redundancy. So we want to avoid repeating information. We've talked about why, storage costs, processing time, update anomalies. You guys familiar with update anomalies? So the idea is that if you have a field, or let's say an attribute inside of an entity, and it's one that's repeated, you're going to have to go in and edit more than one thing, right? So for instance, let's say that we had an employee entity. Okay, so we'll come over here, employee. And you got all the bogus stuff you'd expect from an employee entity. All right, we're going to skip all that. But let's say that we had information about a store inside the employee entity. Now, first of all, what's the problem with doing that? Does the store relate to the employee ID? Not really. Okay, so that's violating normalization, but we'll get to that. Let's just assume we have store location. All right. Do stores always stay in the same place? No. So if we got 100 employees at one store, and let's say this one store changed location, we got updated 100 times, right? So if you failed to do that, that would be an update anomaly. Does that make sense? All right, so minimize redundancy. Are there advantages to redundancy sometimes? You know, I would say that you can make an argument that a foreign key is redundant, and you're right, it is. It's the same piece of information, but provides you with advantages, okay? Now, you could also make an argument for having redundancy for simple use. So let's say that you had a company, and let's just say that no one at the company is very technologically savvy, okay? Could you make an argument to have a non-normalized, say, Excel spreadsheet? Could you make that argument? Could. Would it be right? I'm not here to say. I'll say it'd probably be wrong, though. Okay? So if you think about having, you know, all this information in just one table, it'd be a mess, right? There'd be no edit controls, right? Okay? So let's say someone corrupts a spreadsheet. Is it toast? Could be. So that's why we want to minimize redundancy. Any questions about good relational design? All right. Here is an example from the book dealing with sort of primary keys and relationships. So let's just take a quick look at it. All right. What do you think up here has a relationship with what? No, I'm saying, like, what has a relationship with what up here? So you would say, would it be instructor section or instructor and course? Probably section, okay. And let's see, I don't actually see where they included ID inside of the section entity up here. Is that kind of interesting? Okay, I think it probably is. Okay, they have a teaches, which looks like that's probably an associative entity between maybe course, possibly. Definitely though, section and instructor. All right. Now, do they have to do it that way? Because one section is taught by one instructor, right? There's not 5 instructors in this course. There's 1. Okay. So could they get away with just plopping down the instructor ID into the section entity? Will there be any amount of redundancy there? I'd actually make the argument this is probably more redundant doing it this way than by having the foreign key inside of section. Because look at all the information you're repeating. All right, so for every single section, you're having not 1 record of it, but 2. Okay? And that doesn't really buy you anything, in my opinion. Who disagrees? No problem disagreeing. Now, when would this approach make sense? Exactly right. Okay, so that's a business rule. That's where cardinality comes from. Okay? Cardinality is not something that you necessarily come up with in a lot of cases. In the professional world, they'll say. Okay, I want an assignment in here. I generally don't tell you. Okay? But if you're gathering requirements, you're going to ask those questions, right? You're going to figure out how many people they got teaching a class. Probably just going to be 1. But this approach allows it to be more than 1. All right? If we had instructor ID in section, why could that only be taught by 1 person? So if it's a single attribute, it's going to be an atomic attribute, right? You can only put 1 person in it. Does that make sense? So this is where it kind of gets to where there's not a single right answer. This isn't wrong, okay? Who am I to say that it's wrong, okay? So anyway, what else might have a relationship up here? Department and course? Yeah, you can tell because it's got the foreign key department name right there, okay? So we have a course belongs to a department. All right, anything else you see up here? What was that? Prereq. Okay, so course, yeah, that's going to have. And why does that not go to section? Why does that go to course? Exactly right. Okay, so course is like the blueprint, or you could think of it as being almost like an inherited relationship. It's not necessarily, but you could think of it like that. Okay, to where basically what you're saying is, section, there may be 1,000 sections of English 101. We don't know. What we do know is that the course, prereqs don't change based on section, they change based on course. All right, so to minimize redundancy, this is the correct approach. All right. What about section and classroom? Is there a relationship there? So classroom, and that would probably be what type of relationship, by the way. So a classroom has more than one class in it. I think that's fair to say. You guys are in here for multiple classes even. I know that for a fact. Okay. And then a section, how many locations will a single section have though? So it's not going to be a many-to-many, is it? Okay. So it's going to be on one side, section has one and only one classroom, but classroom has one-to-many sections. Could a classroom have zero-to-many sections? What would make that determination? Yeah, you could go off the actual data. What else though? So yeah, I mean, certainly you could look at the business rules. Okay, that's what's going to tell you the cardinality. So, any questions about this so far? All right, decomposition. So decomposition is basically taking an entity, breaking it into multiple entities. Okay, so like I said, I think someone had the example, I don't remember who, I apologize, but whoever did the employee entity, and they had the pay inside the employee entity, and I said, break it down, take pay to a different entity. Okay, that's an example of decomposition. All right, so what you're doing is you're following logic to where the end goal is that everything inside of an entity only relates to the primary key of that entity. It doesn't relate to anything else. Okay? Now that's a lofty goal. Are you ever going to achieve that 100%? Can you have a functional database without achieving that at all? Yeah. But that's the goal of decomposition. Okay? And there's an idea of lossy decomposition. So I would say lossy decomposition is actually pretty hard to achieve. Okay? Because the idea is that with decomposition, you're basically making a new entity, and at least one new entity, and you should be able to tie everything back with a foreign key. Okay, if you can't do that, that's going to be lossy. You're going to lose information. But like I say, it's actually quite difficult to do that. So I wouldn't even worry too much about that concept. Because as we know, if you have a foreign key on one side of the relationship, you can tie 100% of that relationship together, right? That's all you need. So you got the idea here of a legal instance. A legal instance is simply going to be an instance that's going to satisfy any sort of real-world constraints. Those real-world constraints are most likely going to be derived from business rules. Okay? So if you have a legal instance, that implies the existence of an illegal instance. And that's just going to be an instance that doesn't meet the constraints. So the good news is that when you begin building a database, you program in the constraints. Is it even possible to violate them anymore? Probably not. Okay? So that's decomposition. Like I said, you're taking one entity, you're finding attributes in it that don't relate to the primary key, you're pulling those out, and that gives you a lot of advantages. Okay? One of the main advantages it's going to give you, okay, so instead of having one entity where you can only have, the attributes specified inside of it, you can have, say, the compensation example. Can't people get a pay raise? You can still account for that. Whereas otherwise, you're going to have what's called deletion anomaly. Okay, so deletion anomaly refers to loss of information from basically deleting parts of a row. Okay, does that make sense? So if you have pay inside of an employee entity and you change the pay, that's going to cause what? Deletion anomaly is exactly right. Why does that cause a deletion anomaly? That's exactly right. Okay? Does everyone understand why that's a problem? How would you fix it? Exactly. What's that process called? decomposition. Okay, just making sure you guys got this. All right, normalization. An important topic in databases. All right, basically what you're doing in normalization is the end goal is to find a normalized data model. Now, what is normalization? It depends on which type of normalization you're referring to. There's several. Okay, but in general, you can achieve it by following just the basic practices. Okay, so we've talked about the basic practices several times now. Having logical entities is going to help you be normalized. Having decomposed entities is going to help you be normalized. And for this class, and probably for real life too, goal is third normal form. You can go way beyond third normal form. Okay? Doesn't buy you a whole lot though. It's like imagine you were going down to I don't know. What's your favorite hobby? Someone throw me their favorite hobby. Golf, okay? So, you know, a couple different tiers of golf clubs, right? You go to the thrift store, yard sale, pick you up a basic one. You can play golf with those, right? That's going to be first normal form. All right? Then, let's say second normal form, you're going to go and instead of going to a thrift store or whatever, say you buy a used set, you know, just a couple years old. You buy a decent used set. All right? Going to up your golf game a bit, ceteris paribus. Okay? Second normal form. All right, third normal form, you go buy a decent mid-range new set of golf clubs. All right? Is that good enough for almost everyone? I'd say probably so. All right? Can you spend 10 grand on a golf club? Sure. But the thing is that you're having very diminishing returns. Okay? I'm not a golf expert. Okay, don't get me wrong. Did I tell you guys about the time that I tried to play golf? Okay, I think I told that story in here. You guys know what I'm talking about? Trying to impress someone. I don't want to say it on recording, but anyway. You guys know the story I'm talking about. There's diminishing returns. Same exact principle with normalization in a database. So you have your first normal form. All right, and basically what you're having, you have a primary key. Okay? But just because you have it doesn't mean it's necessarily used for all the attributes. All right. No repeating groups, and it's also already atomic in the first normal form. So, let's say hypothetically, you had an address field, and you just laid, not field, I should say attribute. So you had an address attribute, and you just left it inside of an entity. Is that first normal form? Why not? Exactly right. What is it? Zero normal form, right? Okay. I think I might have said in here before, my hero 0, not the case in normalization. Does everyone understand that? Okay. Let's see, what else rhymes with 0? Not too much, actually. But 0 is bad in normalization. All right. So like I say, just getting rid of a lot of redundancy, not all of it, though. Second normal form is when each attribute is going to be dependent on the primary key. So if you had attributes that were not dependent upon the primary key, they'd be broken out. Or, what's another word for that? Decompose, exactly right. That's second normal form. Third normal form, okay? Attributes only going to be dependent upon a single primary key. All right, and there's some slight differences technically between third normal form and Bryce-Codd normal form. I'm not going to bother to get into them in here because, you know, let's face it. When you go off into the real world, you got yourself a DBA job. Are you going to be having debates with your team about third normal form versus Bryce-Codd? Okay, why not? Because no one cares about that, right? Let's just be blunt, okay? So why spend a bunch of time debating the differences? I don't see a big reason to. Yeah. Yeah. It would, yeah. So basically, what we have is we have this saying. Okay, you guys familiar with the truth, the whole truth, nothing but the truth, so help me God? Okay. Similar saying in normal form. Okay. The key is first normal form. The whole key, second normal form. Nothing but the key, that's going to be your third normal form. So I think the difference between first and second, pretty clear. Okay. Difference between second and third, maybe not so much. All right. So this right here is in second normal form right now. All right. And what's happening is that a non-key column is a fact about another column. All right. So we look at this in a little bit of detail. We can tell that we have a candidate key, which would be both nation and exchange rate. Okay, does that make sense? Now, arguably, exchange rate would actually not be a candidate key. You know, with 190-something nations, it probably would end up being a candidate key, but it doesn't have to be. And with 2 decimal points there, it very well may not end up being one. Okay? And also, you have to remember, a lot of nations use the same currency. Okay, so therefore, I'm going to go ahead and say that exchange rate would not be a candidate key, right? All right, but what we're looking at, though, is that nation and exchange rate, do they relate to stock code at all? Okay, they relate to where the stock is. Okay, so what we're going to do, we're going to take that, put it into a nation table instead of in a stock table. And that's what we're doing over here. Does that make sense? So nation is going to have multiple stocks. Now for this example, we're assuming that a stock has one and only one nation. All right. So no candidate keys in third normal form. If it's a candidate key, you have to break it out, decompose. All right. Another thing to note, column not fully dependent, or functionally dependent rather, on the primary key. Okay, so look at exchange rate here. Does exchange rate depend on stock code or does it depend on nation? Nation. So that's another problem. All right, in third normal form, again, you have to break that out. All right, so exchange rate depends on nation code. Now, nation name also depends on nation code. Because nation name is going to be unique to nation code, you know, technically, you should break it out. I'm going to go off on a limb and say it'd be a pretty ridiculous thing to do, though. All right? That's why I don't get into all these anything beyond 3NF. Some people disagree. I was actually talking with Paul about, you know, how far should I go in normalization. And he and I both agree third normal form is plenty. All right? Because what you're going to end up having is you're just going to have a bunch of tables with like 1 or 2 columns in them. And you look at that and you're like, what's the point? It's the same number of records. If you had it to where nation was its own table in the nation name, same number of records. So what are you buying with these additional forms? Not much. Does that make sense? So personally, I would never beat you up with having you memorize all these different normal forms. I'm not even going to go over them. If you're interested in them, they're in the book. Okay? But I can't imagine anyone in here is interested in 4th, 5th, and all those others. Maybe I'm wrong. I doubt it, though. Am I wrong? It's okay if I'm wrong. All right, we skipped a couple slides here. Here's an example. All right, you got first normal form. Okay, what is that? Someone read that off for us. All right, let's talk about it. What's the primary key? Okay, so most likely, what type of entity is this, most likely? Probably an associative entity. We don't know that for certain, but what would it probably be between? Exactly. Okay, and then they got a quantity as well as a customer credit. All right, so looking at this, there is in fact a primary key, correct? And because there is in fact a primary key, what does that tell us? Okay, that tells us that, we're in first normal form. Okay, all these are atomic. You're not going to have 50 quantities in a single quantity, are you? That wouldn't make sense. Customer credit, I'm assuming that's like method of payment. Maybe it's like customer balance. Don't really know. Okay, but either way, it's atomic, right? I do know that. Now, we break this down a little bit further. We see that customer credit, and especially quantity, does not relate to each other, right? So the quantity relates to the order. I think everyone agrees with that. But customer credit doesn't relate to the order, does it? What does it relate to? Customer. All right, so you get to second normal form. Someone read that. Exactly. So what I do there? Decompose. All right. So a lot of times you'll actually see that second normal form and third normal form be the same. Not always. But in this simple example, does it make sense to break out anything else? So can I say they're the same? You can get away with that in this specific example. Not every example. But again, I would never beat you up with the difference between second and third. To me, they're not that different. All right. Main thing is just no candidate keys. All right. Nothing that could identify everything. That's when you got to start breaking stuff out. So, all right. Functional dependencies. Okay. So functional dependencies are basically going to be what forms the relation from a cognitive standpoint. So, ID. Okay. It's going to relate to each of these different attributes, right? We're saying it's unique to name, address 1, all the information about the person. So that's all it's saying there. Okay, most of the time, I wouldn't say most, I'd say a lot of time, it's going to be multi-valued. But don't get confused when I say multi-valued to think that it's referring to multiple values in a single attribute. I'm referring to multiple attributes. Does that make sense? Could also be multiple instances of a relationship. Okay, let's face it. You got a foreign key. Foreign keys can repeat, right? Primary keys inside that entity cannot, but a foreign key can. All right. So the design process. Talked about this before. Gather requirements. The only thing I'm going to change here is for the model. Okay. You use ERD. Okay, who likes ERDs in here? I like ERDs too. They're great, aren't they? They're easy to understand. Break everything down. It's logical. You could also use voice cod normal form. Okay, who likes normal form in here? One person or two people, okay. It's not necessarily my favorite way to do things, but that doesn't necessarily matter because there's not one way to do things, is there? Okay, there's several. All right, so then, just like before, you build, implement, and test. And you could probably put on here like, reiterate. It's a cycle. You get the point. It's temporal data. Okay, look at the prefix temp. What does that mean? Temporary. Now, what we're really talking about with temporal data, I think a better term for it is time variant. Varies by time. And all that means is that we have a table, we have a date and a time in it. Okay, or maybe just a date, maybe just a time. But in some way, it's going to be variant by time. All right, and honestly, you don't model it any differently than you would anything else. You just plop down date and or time as attributes in the ERD. And you mostly are going to deal with this as you're making queries, okay, which we're going to do that in a couple weeks. All right, so for the date and the time, most likely, if it's a real database, just going to use a calculated field. Okay, there's going to be functions to grab the date and the time. It's called date and timestamp. You guys are probably familiar with that. And the main thing is you run queries appropriately. So for instance, say you have a database of employee pay. Okay, let's say one of the things is the position. So what you're going to look at when you're figuring out how much you're going to pay people. So yeah, you would look at that, but in terms of figuring out the pay rate, I mean. So what's their current position for the time that you're specifying? Does that make sense? So you're going to have to run the queries appropriately. Let's say you're wanting to get the year's sales. All right, all you guys to do is just do where year equals whatever year you want, right? It's not very difficult. All right, there's no point in, I think there's like half dozen pages on this in the book. It's just common sense, though. I mean, really, when you think about it, you got a time column, you got a date column, you got temporal data, commonly referred to as time variant. All you have to do, just inside the where, put the year, or put the time range that you want. It's not very difficult. And we'll do examples when we begin. But for the rest of the class, what I want you all to do is go ahead and work together. And remember that ERD you made last time? I want you to make first and at least second. If you get to third, that's cool too. All right. So I got some paper. And like I said, we'll talk about these. I'll give you guys till about 11:40 or 10:40, I mean.